like this. Always Gaussian surface show dotted one, and this is that point P1. This is the radius R. This is M1, M2. Okay, able to get this one? Now come for this. Where do all this mass, you stand at point P1. This is a Gaussian surface. Where do the whole mass will appear as the mass is distributed symmetrically? As the mass is distributed symmetrically, both the mass of both the shells will appear to be at center. Will behave like a point source. Will behave like a point mass. So therefore, what is the formula? Gm1 r square, Gm2 r square. So what is R strictly? R is greater than B. That's all, no? At point P1. All this mass appears as a point mass kept at the center of Gaussian surface. Yesterday we have made this condition. If the mass is distributed symmetrically with respect to Gaussian surface, then the whole mass appears to be as a point mass concentrated at the center of Gaussian surface as seen from the Gaussian surface. When you are at Gaussian surface here, you are here. Huh? Let me put like this. Now similarly, let's come for point P2. What you should do? You should draw a Gaussian surface related to that. Small ideas is what you have to build up, nothing bigger. Where is the Gaussian surface will come now? The Gaussian surface will come carefully. Where is the point P2? That point P2 is here. Now, who will contribute? So what about the gravitational field at point P2 due to the shell M2? So you do one thing, whenever situation comes like this, take superposition principle. Or just apply the Gauss law, that one. So according to here, there's a Gaussian surface, no? So what will happen to this whole mass M1 of the inner shell will appear like a point mass kept at the center O. Will behave like a point mass. What about M2? No, M2 lies outside. And what is the field at point P2 due to outer shell? Will be 0. You assume that inner shell not there. If this shell is not there, then tell me what will happen. So what is the field at point P2 due to outer shell? Will be 0. So who will contribute the field at point P2? Only the inner shell. So what is the EP2? Should be equal to Gm1 r square, where r is but sir, like a here mass is there. Yes, this mass, if it contributes field, what about other things? The vector sum of the field due to all other sectors, what will happen? Will be 0 at point P2. Now let's come for the last one, point P3. I think directly shall I write 0? Anything? Because the Gaussian surface will come inside. Here it will come. Or the net mass enclosed by the Gaussian surface will be 0. Or by symmetry, the net field at point P3 will be 0, that one. Like this, two thin shells, concentric, 2, 3, 4, any number you can take. The idea is same. Let me take to the next idea. Okay, after concentric shells, so we'll get into previous class. Like we have discussed the field due to the solid sphere, no? And what are our planets? Our planets are what like? So let me have some small discussion. These are